The weather outside is perfect. Time to geek out more. In this lecture, I will show you how we can further develop our digital model of this nightstand. As you can see, we created all these individual bodies using the timeline, and now we would like to actually create shop drawings. To create shop drawings, we have to first create the correct components, and we can sort actually our design. And then with these components, we will feed the shop drawings, including the correct amount of quantities for the bill of materials. So when we send this to a wood shop or a factory, they actually can take these drawings, manufacture everything, also including the correct quantity. Before we continue, let's take a look at everything what we did so far. So we used Fusion 360, including the timeline and sketches and parametric modeling tools to create a concept model. As you can see, the timeline is actually very useful when we very quickly want to do some basic adjustments, proportional adjustments, etc. to our design. We don't really spend much on detail. We spend much more on exploring proportions, shapes, and so forth. And this is very fast. This is kind of like the first part of the design or designing a furniture piece, because then afterwards we have to create a prototype, and then from the prototype we do refinements and create the final design. Now, to create a prototype, if we would give this model to somebody in a wood shop or so, we could definitely give them these pieces and say, hey, have fun, see you in 2 weeks. You can take all the measurements by hand and make me a prototype. Sure, they can, but first it's going to take much longer because I have to do a lot of measurements by hand. It's also going to cost money, plus they might make mistakes. So to prevent all these three problems, and maybe also charge actually for the labor ourselves, we can create the shop drawings ourselves. This is kind of like the last part when the design is more or less figured out. And now we have to restructure our Fusion model or further refine it for the last part. Now, to do this, it's actually very easy. We can click on all the bodies we have, right click, and then we say create components. Don't do this right now because we have to redo this. I'm going to show you one problem, however. So first you would say, yep, there are all the components. This is all good. So here's my left side, here's my right side. Here is the left leg, here is the right leg. But you notice that there are numbers behind. So what does the number actually mean? The number is quantity. And when we call this leg and we call this leg, you see this is leg and leg 1. Let's go to this one here. We call this one also leg. This is now called leg 2. So these are individual pieces, but in our design, there's actually one piece, just 4 times inside the design, mounted onto the bottom frame or bottom plate at 4 different locations. So we have to actually modify how we create the components. So this is now how we do it. First, I will delete this, including the content. So, and here's my circular pattern. Also, this one I will delete. So I have this. These are all my raw building elements. I could give the name to each body right now. I will do this actually after I created the components so you can see what's happening better. Select everything, right click, and then we say create components from body. Very nice. Now we have the components. Actually here we have this group. We can delete this group and then say delete group and expand its content. So there you see, all the individual commands that turned each body into a component. To break this down for one moment is you can see that this inside our timeline talks about how we explore and design the piece. And then the rest, so all these commands, that is actually now at the end tagged on when we prepare everything to create the components. Because we might not necessarily know everything from the beginning. So we have all these pieces created. Very nice. Then we can go to pattern, circular pattern. We go with component, that's correct. And now I need to figure out where is what component. That is one, that is one, and that is one. 3 pieces along the z-axis, 4 times, very good. And now you actually see here, 2, 2, 2, 3, 3, 3, 4, 4, 4. So watch this now, what's happened. So we call this one bottom plate. And this we call actually support angled. And now watch what happens the moment I hit enter. You see, all these others are angled, or renamed, sorry. And they have 1, 2, 3, 4. That's a quantity. Let's go to this one. That is actually, we call this leg. Zack. All those are named. Then we can call this support long. And this is back plate. This is center plate. You can call this top plate, top board. You can also call it apple juice, pumpkin pie. Obviously, it doesn't make any sense. So you use names which are logical. Or left side, right side, and so forth. Now, since I use the term plate, I should be more consistent, because a person who has to read my shop drawing, I should be nice to. Again, as clear as everything is ideally the best, because then support 1p or 2p, support, I think 2p, actually I don't know right now. Let's double check. Ah, 2p, very good. Thank you, Google. The more you make everything logical and easy to read, the more you help other people to read your documents. That makes them happy, but also for your own sake, it prevents miscommunication. Errors are very, very expensive. Very good. So here you see, based on all these components, then we recreated this circular pattern, but this time actually with components. Okay, now we can save. This is very important. So you go save, and now we go to new drawing from design. Okay. Just actually watch this, what I'm going to do, because then we're going to restructure it one more time. So here's my piece. I'm going to be very fast. I'm just only putting this one in. Very good. There we are. Then I will add a projected view of this. I would like to see the bottom. Okay. And then this bottom I drag down. There we are. And then the whole piece here I can click and drag over. So there's my top, my bottom view. If I then go to table, really important is that, for example, we select first or all levels. I actually keep this on first level first. Click and OK. And very nice. You see how everything got balloons added to it. there is now, when we zoom in, bottom plate, support angled, lag, support long, back plate, center plate, and so forth. And it gives the number. So 8 is right plate, and then the quantity. The material, this is obviously wrong. We have to fix this. So now here I can click and drag these balloons, move them around along edges to make this easier to read. Maybe for the feet or that construction below, I move those balloons actually to somewhere else. So this is actually then more separated. It makes it a lot easier to read. Okay, now there's one problem. It's more a readability issue. You see it says bottom plate and then support angle, the leg, support long, back plate. So it's the top and the bottom parts are kind of mixed a little bit. That's not really ideal. So let's delete this drawing. And what we will do now is we will create 2 more components and then put actually these components into those. So right click, new component, and then we can call this, for example, frame. And then one more time, right click, new component, and let's call this stand. Okay. So now here we have 2 components. And currently the icon you see here means this is all just a component. Now we can select bottom and top, right, left, and back plate and center plate. Yeah. And then click and drag this into frame. And you see it on the frame icon now changes, similar to here. So this is the component, and then these are the subcomponents. You can hide this, select with Shift all those, and drag it into stand. Now you see also the browser is actually a lot easier to navigate. This is also much easier to turn on and off. Makes more sense, no? Okay, save. Good. Again, it's very important to do save because otherwise the drawing does not know what we changed. Now we go to new drawing from file. So now you can actually follow this. So full assembly, yeah, that's all fine. Also template and ISO, now it's basically the imperial or metric system. ISO, as you can see, this is A3, so European page format. If you go with ASME, then you have the imperial, like with inches, etc. So it's up to you what you want to work with, and also who do you create this for? Is this for the worldwide market? Is it for the US market? Very good. Okay, there we are. Now I will do exactly the same. So I will add a scale. Yeah, that is good. There we are. Okay, and then I will add the projected view. When you go down, you see the projected view at the top. That's not what I want, which is why I show it actually from the bottom, move this up, and then I can still forever move this one down. Because it's a projected view, if I move this one, you see the other one stays in alignment. That's actually quite nice. Okay, very good. So let's click on this, click on there, and whoa, what's going on here? Where's all my stuff? It says frame and standard. Yeah, this is all I have here. When I open this, well, what about all these parts? We have them. So why don't we see all this stuff? So the bill of materials basically lists now on top the highest hierarchy, well, frame and stand. We have 2 objects there. Well, makes sense. Now we can make actually a new drawing. Go to base view. click, okay, projected you, click, okay, drag this one down, drag this one there, there, click. And then here, this is important now, not first level, say all levels. And you see now how the list is much longer now. Click, and then we can drag this to where we want. Very nice. So now you see item number 1, that's my frame. Item number 2, that's my stand. And then 2, 1, 2, 2, 2, 3, and the quantity. You see the software does pretty much all the work for you, which is really, really nice. Now I can, again, rearrange elements if I want. Again, try to do this in ways that helps readability. So here I put this balloon in there, the foot can stay there. We can also add actually more balloons to there too. And you see, so this is 0.5. So 0.5 is right plate, that is correct. Can drag this to the outside, delete this. This here I will put to there. Same here, so it makes it simply easier to read. Maybe I move this one up a little bit. Yeah. Okay, good. Let's save this one. We can press S to save, and then because this is a drawing, I call this mid-century side stand drawing. That this is all stated as material is kind of wrong because sorry, as steel. Let's go back to our design, and then you might say, well, what's going on? We see that this is finished. This has an actual 3D wood look, but this is appearance. That's just the look. That is not necessarily the physical material. So these are two different things. Let's go to physical material, and then everything will look kind of like this grayish. And then down here we have wood. Scroll down. Then we have here something called MDF, medium density fiberboard. That is what actually is being used here for these parts. That is not a particle board, which is more coarse. That's actually an MDF. Again, that's a very fine pressed material, doesn't have any surface structure or grain, can be perfectly sanded and painted. And then for the legs, well, if it's up to us to decide what we would like to use, now use, for example, particle board, plywood, poplar, walnut, wood. We could, for example, say this is all wood, and you see, because these are components, I only have to do this to 1. You see, this has actually material. Again, this is just only a look. If I click close now, this is all written by the material for the rendering. So I hope actually what this showed you was this is for when we make a rendering. The other was really to document the construction material. So when we hit save, yeah, and then go to the drawing, you will see nothing changed. But, oh, there's a warning, and up there's a warning. Click on it, and that whole thing expand a little bit. We can click and drag this, and now there it says wood, 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 particle board, MDF. Fantastic. Now actually the person that has to build the piece not only knows the name and the parts and the quantity, but I can even tell them what material I want. Amazing, no? Yeah. Okay, let's do one more piece. And now we go to base view, and the next step is really important. I just don't click because I'm using the existing element here. I click on create new. We'll see what the big difference here will be. And 5. Click here and OK. So the stand I would like to turn off. And for the frame, I only would like to see this. Well, this is good. Then let's create a projected view. On the right side, when we see the outside, I would like to see the inside there. This is better. And here you see we have all these individual views. And here now I have a different view because this is all turned off, but not here. So the stand, etc., is all still present here. So that's why when I said it's actually a little bit important to, oh, look at that, just way too many. It's quite important to make individual views for ourselves. Good. So here we don't really want, I mean, we can put in this. It's not really helpful. In this view, actually, now we would like to document this. So let's give this some dimensions. Now, when it comes to dimensions, there are many ways how to do this, but I always find the easiest way to think about it is it has to be readable. Dimension it in an orderly fashion. Different companies might have different styles too that you have to adapt to, but in general, think about it how we dimension an object in engineering for an object or for architecture. It's all about readability. So for example, what is the overall width and the overall height? Okay, now with the dimension tool. Well, maybe how high is this and there? And what about this one here? And I put this one there in between. So it's nicely stacked. Then I can do the same here, bring this one up. Okay, good. Yeah. If I want, I could do it also this way and then this one down there. Press escape. This one I remove. So it's nicely grouped. Okay. Now I have the total height, which means I don't actually need to add this. It's pretty much the same because I can really see from this, I have this dimension. So, but what I can see from this view, what I can't see from here is the length of this tiny line there. So I could go ahead and say U or 5. Very good. Yeah. And that's kind of like actually all in terms of dimensions I need. So let me show you what you do not want to do. I mean, you can, but it's actually just adding it more, making it more confusing. I'm going to make it really confusing on purpose. When you click on a dimension, you can also then later drag these around. Very good. There. Now you can see it's like a chaos of lines. This is not really very good. So this can go, this can go, this can go, this can go. We can keep this one here because I have this dimension up there. I will actually add this one on top. There, now we can see it the same way. Very good. Nice. Okay, now press escape. The last thing here, maybe we have all these different pages. So we can double click and then we could say this is our left panel. Finish property, very nice. And then this is actually our can maybe call this bomb parts, and then this one is maybe maybe we can call it maybe bill of materials assembly because it's just the two pieces, or they're kind of like the units, and then the individual pieces, because when we have the frame or the stand, maybe understand we can mount individual frames. So with that said, let's actually make one design or drawing only for the stand. There we are. Okay, here we are. Again, we go new, and then I would like from the beginning to have, yeah, maybe this one will be fine. And 5, very good. I bring this to there and okay. And then frame I height, that is good. Then I can do my all levels. There we are. Again, also here, what is this? 2.3 support long, that is good. This is easy to read from here. If we want, it's not always good to put these pieces in a drawing because then we have lots of lines that are crossing. You saw actually how this does not want to sit somewhere. It needs to be attached onto a line. So when we move this, you see how this all moves with it. Okay, pretty cool. So one last for maybe the box. So base view, and yeah, there we are. 1 to 5. Again, let's see, we go, nope, not this view. Yeah, this looks actually good. Okay. Good. Turn the stand off. All levels. Long. Good. So we have frame bottom back 1.2. Oh, where's the back plate? We don't see it. Well, we don't see it because it's visually actually not called out. So how can we do this? Well, we could maybe add a back plate or a view of the back, but much easier. Simplicity again, double click this object, and then we go back to the drawing view, and let's simply turn on visible hidden edges. You see, there we are. And close. We can delete this and go back and backplate. There it is. So see, now we can actually see everything. What about when we turn this into a front view? Okay. Instead of remodifying the balloons, it's, as you can see, easier to just delete the bomb and then re-add it. Yeah, there we are. So 1.3 is the center plate. So I will put this one to there. Very good. 1.2, that is the back plate. 1.1, that is the bottom plate. 1.4 is the top plate. Even try to line these up so they're horizontal. Yeah, and there we are. Now we could call this actually, this is not bomb parts, but this is bomb frame, or however we named actually that design. And then we click save, and that whole design is finished. Great. So I hope with this video I showed you actually a good understanding of the whole process, because this is essentially what using digital CAD for is. We use the direct modeling to quickly explore some ideas because it's copy and paste, and then we can rebuild it via timeline and parametric modeling and just be more specific. And we're still kind of like in the creative phase. But then when we want to make a prototype, then we generate our components, put the components and into a structure, kind of like how we can sort it here. The frame and stand, that is optional. You don't have to, but I think this just simply makes things a lot easier. And then we can create very well detailed and documented and easy to read technical drawings just with a click of a mouse. And the cool thing is if we now adjust one thing in our design and hit save and go to here, yeah, there's a warning. Zack, it got updated everywhere. So all our multiple drawings are again updated. In the past, that was basically requiring a lot of manipulations or manual updates of all these drawings by hand, which introduces logically the problem of always overlooking something, making a mistake. That's not very good. It's very stressful, very expensive when then there is a mistake. In the prototyping, and you see here, zack, 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 they are all correct. And that's it.